For the third and final time, I am Thor, god of lightning. Fabulous to see so many of you. This marks the end of our culinary journey through the lightning talks of EMF. This is the brandy and cigars, the little mini chocolates, the wafer thin mint. So we have got for you first up machine ignorance. Would you like to use that?
What's it do?
It advances your slides.
Oh, that's good then. Can we see the slides?
That's what the HMO.
Can they go down? I've just got you on now.
Okay, 5 minutes on the clock.
So, the source of the enigmatic images which I have been liberally and literally littering the camp with. You can go and read Sprott circa 1993 for yourself, but they are created by recurrence relations, or if you like, coupled quadratic difference equations. X of n plus 1 is coefficient A1 plus coefficient A2 times xn, and so on and so forth, if you want to think of it that way, which I personally do not. I would rather a nice, neat, vectorized matrix operation which allows me to try out many different sets of these 12 coefficients all at once. And I'm calling it that if I'm doing it in NumPy or PyTorch, it's therefore industrial, because there's not a lot of steam hammers in Sheffield these days, unfortunately. So there are 25 different values of the coefficients from minus 1.2 to 1.2, intervals of 0.1. You can give them a name, or you can give them a letter rather, so each weird shape has its own name. I'm not going to explain what Lyapunov exponent or correlation dimension are, but they are used to filter and choose the attractors, that weird images that are deemed aesthetic. So, each point, take its row, take its column, pretend that they are real and imaginary parts of spectra, and inverse short-time Fourier transform them. Multiply them by a window function, hand-waving, complex conjugate, etc., etc., to get a real signal. I could have just used the discrete cosine transform. But hang on. Each individual point is in strict sequence, but the sound it makes is determined by all the previous points and all the points to come. Is that valid? I needn't have worried. You got to teach, and in everything you learn will lead to the fact that time is eternal. Point to the fact that time is eternal. Sorry. So, rotate 3 of the randomly chosen coefficients around a circle, and you can perturbate the attractor and produce lots of images and make lots of noises, and they move. How long have I got? Ooh, sorry. Do you know what? Oh, someone full screens. I'm going to slum it. so on and so forth. Thank you.
All right. So ordinarily I would actually have done this with the speakers in advance. Obviously we had some technical issues, but I'm all about transparency. Gentlemen in the second row there, make things open. It makes things better. So, has somebody got getting started with PLC? Because I've got no idea. Getting started with PLCs, everybody. Big hand. Thank you for that.
I'm not entirely qualified to talk about this, but it's more like the things I've learnt rebuilding the fluorescent clock that's in the back of null sector. A lot of people probably don't really know what programmable logic controllers are unless you actually work in industrial automation. And one of the reasons I'm not really qualified to do this is I don't actually work in industrial automation. But if you imagine any factory that makes things, cars or whatever, all of the processes for stamping the metal and moving them forward is going to be automated somehow, and the way that operates is with a PLC, and it's just a tiny computer, and much like a tiny computer, it's got a CPU and it's got a power supply, and the only thing that makes it different from, say, having a Raspberry Pi is that you've got a really large amount of input and output capability, far surpasses anything that Raspberry Pi can possibly offer. And they can also directly switch mains voltage. Don't really need to add anything other than that. Which one should I talk into? Please don't make that happen again. Switch mains voltage. Hello. Oh, I don't trust microphones. I really don't. Unfortunately, programming a PLC tends to require Windows at the moment. It's getting better. It's getting slightly better. So to write stuff, you have a terribly bespoke bit of software that is produced by the manufacturer of the PLC. Bad microphone. There's two ways of writing it. One...
Get closer.
I'll get closer. Okay. It's frightening. Two ways of programming it. One of them, it looks like a sort of circuit diagram. Contacts on one side, coils on the other. Contacts is just like inputs and coils are outputs. And the other way of writing it is instruction list, which is a little bit like a flavour of assembly language, but without... It's only got like 15 operands in total, so there's not a lot it can do, which kind of gets me on to the next point. Things PLCs cannot possibly do. AI. A load of people have said to me, can't you just make the clock think for itself? And, no, you can't. You've got to tell it what to do. You've really got to tell it what to do. There's no magic in there. But if you want to just like control relays and turn things on and off and set up things like safety interlocks so you can't put your hand in the machine when it's operating because it knows where you are, so you have a light gate, and if it detects you then it won't let you do anything else. And the way that the clock works this time is that you can control it from a web app now, and that converts to Modbus, and the Modbus gateway is on my server in the cloud, and then talks back to the PLC and says, set these coils that correspond to these bits of I/O bus on or off, and that makes the display work. I think I'm probably talking quicker than I've got slides for. Oh no, that's okay. They're cheap. They're really cheap second-hand. They're incredibly expensive if you want to buy them brand new. Prices between, I don't know, 150 quid and tens of thousands. but they do turn up on eBay really frequently. And there's almost, you can't like get one on eBay and get it bricked, because there's just a pin. You just take the battery out and it forgets everything, and then it's yours to do what you like with. And then on the side, you can like add more input-output modules. So the one I've got has 40, which is a roughly split of 20 in and 20 out, plus another 16 on the side, which is rather handy. Yeah. I'm going to go to the bar later. If you want to talk about PLCs, find me.
Okay, so to cover the incredibly slick interchange that we are about to do, your favourite way of finishing a meal? Any desserts? Do you like desserts? Cheese? Wine? How about mushrooms?
Oh, okay.
That was the cover. That was the cover to come and swap out the laptop.
Yeah, sure. Thank you.
Hello. Oh, there we go. Okay. Hi, my name's Luke, and we're talking about fungus. So, and how fungus could be our future. Okay. So, that's basically what I just said. So we have a massive problem right now with waste, and in all sectors, and I think fungus could be our solution. So, world's waste right now. We are using way more than ever, and we are replenishing not as much as we are using. So we're taking about 100 billion tons of natural resources out of the ground each year. And the main sectors of this is construction and agricultural waste, because we just build buildings and then tear them down and throw them away. And agricultural waste, we've got basically loads, we just want certain parts of the crops, and loads, again, just go to waste. But this isn't how nature works. So, nature works in a closed-loop system. Everything gets recycled and reused, and that is done from mycelium. So, what mycelium is it's a root structure that basically is nature's recycler. So, as you can see in the picture, you have a tree makes a fruit, animal eats the fruit, animal dies, the mycelium comes and turns that animal into nutrients and adds it back into the soil. And then it just goes round and round, circle of life. What is mycelium? Okay, so we're talking about fungus. Some of you probably seen Last of Us, and some of you probably were students and left things at the back of your fridge. So there's lots of different types of fungus. What we're talking about now is mycelium. So this is basically, if you imagine a tree and an apple, that is a mushroom, the fruiting body, and mycelium is the actual tree itself, but instead of being out the ground, it's under the ground. So what it does is basically a root structure that decomposes everything that dies, so all the leaves, all the animals, and essentially puts it back into nutrients into the soil, and has a symbiotic relationship with plants, where they basically trade things like phosphorus from the soil, and it trades with the plants to get carbohydrates that they get from photosynthesis. And this is basically how everything was created from all plants and all life. And we know nothing about it, and we need to learn more about it. Okay, so insulation. I chose insulation because it's one of the biggest problems in the construction industry. So why is that? So, right, it's made out of petroleum, and we take that out of the ground. It has massive carbon footprint. It's really toxic. It's really bad for you to be in your house. It's really flammable, and when it's flammable, it releases even more poisonous toxins. Okay, so how are we going to relate these two things together? So, this is the process, as I just said, to make petroleum, take petroleum out of the ground, make expansion foam, make insulation out of it. Well, I thought maybe we can take agricultural waste from one industry, such as straw, rice husks, things like that, use that as a substrate to grow the mycelium on. So this ends up being carbon negative, because you're taking a waste product from one industry and reusing it. Instead of it decomposing or burning it, which is what a lot of the time we do, and adding carbon back into the atmosphere, the mycelium actually will eat it and digest it and grow out of it. So you're actually upscaling it. So I'm talking really fast because I've made way too many slides. So this is the process. So you basically take the agricultural waste, say straw, you have to sterilize it. So the biggest problem is other fungus or bacteria or mold getting in the way. So what you do is you sterilize it, then you take spores, which are basically seeds for mushrooms, you inoculate that substrate, so the straw, you let that grow, and you essentially just put it into a mold, into any shape you want, and it will grow into that shape in about 1 to 2 weeks, depending on the size. Then you put that into an oven or a kiln to stop it from growing, and you get like a spongy-like foam, almost similar to styrofoam. And then you can put that into your walls. And I did some tests. Oh, and once you're done with it, you can take it out and put it into the ground, and within 45 days, it completely decomposes, and adds nutrients back into the soil. And then the circle just goes around again, like nature. So this is a quick process to what I did. Basically got some straw, boiled it, sterilized it, got some grain, which inoculated the straw, got this little panel I made, put it in the oven, and here we are. Cool. Tests. So I tested this and found out that it actually had better thermal resistivity, and it was better soundproofed. And also, I took a blowtorch to it for about a minute and found out that it's really good fireproofing as well. So this is amazing. And I want to quickly... Oh, wow, I've gone ahead of time. So I'm not the only person. There's lots of amazing things going on right now with mycelium. Some people are using it to make polystyrene, essentially packaging. So you can make, instead of using polystyrene, you can grow this into any mold shape you want. You basically just make the shape and put the mycelium in it, and it will just grow into that shape. And again, everything's completely combustible. People are making construction bricks out of it, and that's an exhibit of people making bricks out of it. You have leather. People are making plywood. This up here is, they found out there's a type of mushroom that makes, that eats complex hydrocarbons like plastic and oil, and essentially you can drag it through oil spills and it will eat that up and make mushrooms. Recently I found out that the people are trying to make computers out of it, and because basically, like the movie Avatar, it's based on mushrooms, and they transfer information, look up something called the Wood Wide Web, and you transfer all information through nature and how trees talk to each other, and they found out that they, unlike normal computers, they can do complex calculations in parallel other than series. Thank you very much.
Yeah, well that's... Yeah. Okay. Got one more. Because Thor is open to bribery, we have got 10 minutes. Sorry? And because I believe this next talk is going to be very relevant to the interests of at least one person in this audience, a bonus round replacing the internet with QR codes.
Yes. I should have said this. I've only got USB-C. Is that? No, there is no USB-C. Cool. Sorry.
So you do it through interpretive dance?
I could try and do it through interpretive dance. It's easier on a laptop, though.
I don't think I've got the...
Was that what wasn't plugged in before?
No, this was the...
Come on, I can do it here.
Yeah, but where would the start?
I can look it on the URL.
Okay.
That's all right.
I mean, it's not my laptop. Like big bars on their own basis, then I will probably get that one.
Sorry. You might need a bit more color. Yeah. No. Sorry, this is... Cool. Yeah. QR. Yes. Slides. QR. X. Perfect.
on technology, ladies and gentlemen.
Cool. Hey, thank you so much. Cheers. Yes, I was going to talk quickly about the idea that I came up with recently about trying to replace the internet infrastructure with QR codes. Basically, when you've got, say, a laptop and a phone, you want to send a message between them. What you do with that is it involves quite a lot of different things. So your phone sends this message, it goes to the cell tower, if it's on GSM network, it goes through all the stuff, including the internet, routers and all that kind of stuff. So I was wondering, is there a simpler way? And what I thought is, like, we have this thing called QR codes, so you can basically show a QR code on your phone and then use a camera on your laptop to detect it, right? So that way we can kind of send content between the two devices. And then to make this bi-directional, we can actually send another QR code, display another QR code on the other device, and then do the vice versa. We can build this. Yeah, we can. So we've got everything in the web that we can do this. So there's QR code generating libraries. There's barcode detector native in browsers. And then get user media gives us like camera-facing cameras. So this is the code, but I'm not going to skip over that because I've got 4 minutes. So yeah, this is an example of this. So this is basically showing a QR code. I'm going to allow it to use my camera. The way this works, so basically both devices will... Oh, I don't know why that's... I don't think I've got permissions. Oh dear. Do you know how to...
There's an icon in the top.
That one?
Yeah.
Shall I refresh it?
Oh, you've got the block on.
Yeah, so the way this works is like both devices visit the same QR code, and the first part of the kind of protocol is if one device sees the other device. Terrace, I guess it's working on your phone. You could, yeah. Do you want to come up and we can send a message to each other? Does that work? Yeah, perfect. Okay, cool. Brilliant. Right, okay, so what I'm going to do, hey, hi by the way. So if I scan your QR code, oh, sorry, I need to visit the same page. Oh man, this is really smooth usually. Right, okay. So now our two devices, will identify each other. And so now they've kind of changed this is not so interesting, but basically I can send a hello world, so I'm going to send a message, and that queues up in my QR code. Terrence's QR code should read that. And
Hello world.
And yeah, so that's basically how it works. There's also there's some other examples here which I don't really have time for, but I implemented a chat application that lets you kind of like send messages back and forth with like delivery receipts. I implemented QRPC, which is kind of like gRPC but a bit more kind of QR code based. The speed test, spoiler alert, is I think it's 5K in about 20 seconds. So it's not very fast compared to broadband. And then the last one is signaling. That gives this demo of like it uses that QR code socket to negotiate a WebRTC connection between the two devices, so you then get a high-speed connection, which is kind of fun. But yeah, I think I don't really have time to do that, but thank you very much for bearing with my laptops and all that kind of stuff.
All right. That is your lot. So thank you so much to all of our speakers. I think some of them are going to be in the QA tent, or Q&A tent, I should say, or the robot arms. If you have got something you are passionate about, interested, but you're not really sure it can maybe fill an entire 30, 40-minute slot, please do consider submitting a lightning talk for EMF. It's a fantastic way of just getting a bit of experience, talking in front of a group of people, and just sharing your joy. It's a fantastic experience. I did it 6 years ago, and it was one of the best things I've ever done. So thank you so much for coming along. Let's have a little bit more love for all of our speakers and their very glamorous assistants.